All right, so let's dive right in. So if we think back 40, 50 years ago, what was very common to find inside of an air handler was an axial style fan, like I'm showing on the screen here. Vane axial style fan, a lot of times the propellers were variable pitch propellers so that they could be adjusted in order to accommodate whatever the flow is required through an air handler. And then the transition kind of went to a housed centrifugal fan. So what I'm showing you here is a double width fan. You'll notice that there's a large motor. It's belt drive. In many cases, they utilized IVDs or inlet vane dampers, again, to meter flow through the fans because a lot of these fans were not on VFDs at this point in time. Then the industry moved more toward large unhoused plenums, still belt drives, still single motors, still single fans in a lot of cases. And then more recently, we've seen the trend move toward more smaller fans. And a big reason for this is because VFDs became more readily available. Permanent magnet motors or electrically commutated motors became more available and more cost effective. And the most recent trend now is toward fan arrays. So fan arrays are more compact, lighter weight, and there's a lot of benefits that come along with fan arrays, which is what my next slide is. So why do we use a fan array instead of our traditional fans, either housed or unhoused centrifugal fans? Well, wheel size aligns better with motor speed. So what I mean by that is when you look at nominal motor speeds, they're going to align better with smaller fan sizes. So if you look at a large belt drive housed double width fan as an example, they're going to spin at maybe 600-700 RPM. Well, most motors in the industry, or the common motors in the industry, are going to be a 4-pole 1800 RPM motor. So you have to use belts and drives to get that down to a fan speed. So with direct drive, smaller fans, you get better alignment with nominal motor speed. Redundancy is also a big advantage. So if a fan does go down in a system, the system can typically ramp up to cover some of the performance of that down fan. Whereas with a housed centrifugal fan or a unhoused centrifugal fan with a one motor, any failures in the motor, the drives, the bearings could mean that the system is down entirely. Low maintenance, so in a lot of cases, the motors are going to be direct drive and most of the time permanently lubricated so that there's virtually no maintenance on the motors. Serviceability is an obvious one. You become much more capable of dealing with the lighter weights as a single person, where if you think about changing out a 100-horse motor on a large double width fan, that's going to take a small army to do it versus pulling a 5 or 7.5 horsepower motor off of a fan and replacing it. Lower sound, when you got a large fan, whether it's a housed or unhoused, they're creating a lower frequency, which is going to transmit through buildings and structures more. Where if you got smaller fans spinning at higher speeds, they're creating higher frequency sounds, which are much easier to attenuate. Lower vibration is kind of intuitive as compared to the traditional fans where there's more moving parts, belts, drives, pulleys, bushings. With the direct drive fans, you have less vibration. Shorter axial length. In a lot of cases, we've got compact plenum style fans that are now hung on the wall, so they're maybe 18 inches deep versus maybe 4 or 5 or 6 feet with the traditional fans. And then operational flexibility. There's a lot more flexibility with variable volume systems and more controllability.